investigate answers in this to this question and this size.
Okay, so let's key in on factored roots. If it's factored, you got a bunch of parentheses like x minus 2, x minus 3, x minus 4 raised to the second power. Remember, there's a balance sometimes, right? You can get the roots so easily, right? But when it's not factored, like here, we run into a problem. This will still cross the x-axis, or it should. But how do you figure that out, right? You could use Desmos. You can use a graphic calculator, and you'll see that, okay, it crosses at this number, right? Whatever, right? So what we're going to talk about today is how to actually divide polynomials so that you can actually find these other x-intercepts that may not be obvious from factoring. So first off, you guys remember this chunk, right? Like if you have a bunch of stuff you want to multiply it out, you put a box, right? Like, oh, 3x minus 2, put 3x minus 2 on one side, let's put these terms on the other side. Let's multiply it all out, right? And you know, this time this goes over here, this time this goes over here, so forth. And all these terms combine what the product is, right? So if I multiply 3x minus 2 with all this chunk, I would get all this. But you could do 3x times each of these 4, negative 2 times each 4, and then combine everything afterwards. Or you can be more organized and put in a box. And we're going to be working on the box more often. But the box, I think, is a good thing to do. So if you think about, Evan found this, right? X minus 2. So 2 is an x-intercept, right? If 2 is an x-intercept, what was the factor it came from? X what? Good. It has to be x minus 2, not x plus 2. If it was x plus 2, what would have been the roots? It would have been negative 2, right? But if it's x minus 2, the x-intercept would have been 2. So what this tells me is that x minus 2 times some junk, I don't know what the junk is exactly, because I can't do it in my head, is going to equal the entire polynomial. I know this, right? Because I expect that to happen if 2 is an x-intercept. So how do you find that junk that x minus 2 is multiplied to? What do you think we have to do to both sides to get that junk by itself? Divide by what? You got to divide by x minus 2. And that's what we're going to talk about today, how to divide polynomials. So let's take a look at it over here. This is actually, I think, probably the best thing CPM does. I've taught this to my honor students that they've done polynomial division another way. Like, no, we were going to throw it out the window. This is the way to do it. I actually do a plot CPM for this. This is actually really good. So first off, do you guys know how to do this? Like how to multiply this out? So how do I get started? What can I do first?
Wait, what's the x?
Oh, that's just a filler. Don't worry about that. It just means you're multiplying. It's being stupid.
Oh, so that doesn't actually.
No. It's just here's the true boundary. That's the true boundary. I'll draw in blue. Yeah, I don't know why I do it that way. Actually, that's the one thing I don't like. I don't like the way they do that. That's confusing. Because you were confused. I was confused too. Okay, so let's use green to multiply. What's 2x minus 4x cubed? Yeah, and you just keep going in this motion, right? 12x squared, sorry, 12x cubed, negative 4x squared, negative 10x, and you keep going, right? Negative 12x cubed, negative 18x squared, 6x, yes, and 15. Does that make sense? That's very, very organized, right? Hey, 2x multiplied by each is 3. 4, sorry. Negative 3 multiplied by each is 4. Great. What do I do next? After I've all multiplied out.
Like math.
Do the math. Do math, right? Combine, right? We combine like terms. If you combine like terms, does 8x4 combine with anything? Does negative 12x cubed combine with something? Yeah, that goes well. How about negative 18x squared, negative 4x squared? Good. Keep going. And plus 15. There you go. So what this tells me, what's in green? Green's final answer, right? That's a product. You produce something. That's what we call a product. You produce this by multiplying. What if I took this product and divided by 2x minus 3? If I took this, what's in green, divided by 2x minus 3, what would be the result? Up above. Yes, exactly. Right. If I did 12 times 5, which is 60, what's 60 divided by 5? 12, right? I expect that to happen. So now we've seen this. Now we're going to work backwards. And they call it Polydoku because it's like Sudoku. I don't play Sudoku. I play Wordle and connections, but anyway, if you're into Sudoku, then you're familiar with this. I'm probably mispronouncing it too. All right. So this has to be 2x cubed. Okay. If I keep going, if that's x and negative 2x, that has to be negative 2x squared. So far, you guys are okay with the first two I just did? So this required, well, that required multiplication. Plus it. You gonna close window? Yeah.
No, I'm good, I'm good.
Okay, so x, 2x cubed, 2x4, x, negative 2x squared. We can keep filling it out. What are we gonna put in the lower left corner? Yep. Okay, if you have negative 4, that's be negative 3 x squared. Good. Yes. So therefore, this is negative 3x cubed. What I'm going to put right below negative 2x squared? 8x. What am I going to put? Ooh, this gets interesting. Hold on a sec. Oh yeah, I don't know. Yeah, well, hold on. Maybe it is possible. Let's see. That's going to be 2. So we have 2x4 for sure. Negative 11x cubed for sure. Plus 10x squared for sure.
Like a regular number.
Okay, this is good. I'm glad we got stuck here. 2x4 for sure, right? These combine to negative 11x cubed. Great. 12x squared, 2x squared. 10x are great.
Why is there 12 extra there?
Great. This is good. This is good.
Oh, then we have
Yes,
to
great
find
question.
what it makes.
What do you add to 8x to get to 12x?
4. No.
Good. You get 4x. Yes. This has to, I'll put in pink so it stands out. This has to be a 4x. See, what are we doing when we're adding these? Aren't we just combining these diagonals? That's going to happen often. If you combine these diagonals, what did this diagonal add up to? 11x cubed. What's that add up to? 10x squared. What does this diagonal add up to? 12x. Yes, that we were stuck.
4.
I was stuck.
4.
Because I'll be honest, when I don't review these notes. I just do them for the first time with you guys. So I do a slightly better job at that period. Sorry, but still, it's good that you see me stuck because I'm being more organic about it. Like, okay, well, I didn't know, but it's 12x, so it has to be ax and 4. So this has to be a 4 now, and negative 16. So what this means, I'll write on the board. Obviously, I'm not doing this in video, but 2x4 minus 11x cubed plus 10x squared plus 12x minus 16. That's going to be the result when I do this. 2x cubed. Sorry. That divided by, my apologies, that divided by x minus 4. That's what I meant to say. That divided by x minus 4. Guess what's up top? The 2x cubed minus 3x squared minus 2x plus. Sorry, that's minus. That's plus 4. That looks terrible. That gets me the quotient. If I took this product and divide by x minus 4, I get what's on top. Just like I did 12 times 5 is 60, 65 by 12 is 5. Or 65 by 5 is 12. So now we're ready to actually do the division. Let's take a look at this one here. So this is what's happening. We call this the product.
Response.
Correct. We'll figure it out. We call this a divisor. And that's a dividend. So we got divide the dividend by the divisor. If you think about it, this had to have been a 6x cubed right here. What do you multiply to 2x to get the 6x cubed? So that has to be 3x squared. Okay. That's be 3x squared. All right. What do you multiply to? What do you get when you do 5 times 3x squared? But I see a 7x squared. What do I combine with this in red Yeah,
Right
7x
there.
squared. Yes, negative 8x squared. Yes, it's like a puzzle. Negative 8x squared. Therefore, this has to be negative 4x. To guarantee the
Oh,
negative
to
8x
get
squared.
oh yeah.
That's the negative 4x. Okay. Let's keep going. What's 5 times negative 4x? But having negative 16x.
4.
So this has to be a 4x. Making that a positive 4. And that becomes 20.
Why is that a 4? Yeah, because 4 times 2 is 8.
Oh, you're right. It's a 2. See, I'm not perfect, guys. Good. Good. You guys are on it today. Okay, I did catch myself though. You know what? I would have caught myself. I'm honest. Yeah, I would have caught myself. But that's a 10, not a 20. That'd have been a 10. So I would have caught myself. So that's called division. That's polynomial division. We're gonna do this over and over again until you guys get the hang of it. That's actually the big idea for this unit. All right. So what happened in the previous problem? Let me zoom out just a tad. So we'll move on to the next page. What happened was this. I divide this by this. That was a division problem. And what did I get? Well, I already erased it. That's lovely. That's awesome. Okay, 3x squared minus 4x. Let me write down. We got 3x squared minus 4x plus 2. That's because 2x plus 5 times 3x squared, guys, quiet please, minus 4x plus 2 equals 6x cubed plus 7x squared minus 16x plus 10. Let me clear that. Because what we're doing, excuse me, is dividing all this junk by that right there. That was a division problem. The result of dividing this by this was this quadratic. Hence, 2x plus 5 times this equals all that junk. What if there's a remainder? It does get a little funny, but we'll deal with it. This didn't have a remainder. It came out clean. You'll see. I'll show you in a moment. For this one, it's just 0 because it came out clean. Okay, what if there's a remainder? Okay, so we'll worry about that. Well, actually, you know what? Let's do this right now. Here. And then we're pretty much almost done. Yeah, awesome. Okay, we're doing great. It's the time. All right, so I'm gonna do this again with you guys. Hold on. Okay, here's how you generate this. Okay, when you see this problem, this will be a problem in the final.
Do you want us to draw like the box?
Yes.
The goal?
Yes, I do. And trust me, if I do long division, you guys will hate this. Long division sucks. It's terrible. There's another process called synthetic, which I'll teach you guys. But this is way, like, trust me, you have like friends at the schools, or we have someone in pre-calculus are doing long division. You slap in their face, like I have a better way because this is much better.
Did you always know the first number on the top?
Correct.
Be the first top.
Correct. Yes. So the top number is always going to be the top left corner. 2x plus 5 put off to the left. Now, what am I going to put in the top? What am I going to put above here? What's going to go here, guys? What's this? 3x squared. Yes. 3x squared. Yes. 3x squared. Well, hold on. So let's slow down.
15x squared.
Then 15x squared down here.
Then you have to negative 8x.
Then this has to be negative 8x squared to guarantee the 7x squared. The reason these diagonals have to add up.
Are they always going to be diagonals?
Yes. All right, 100%. This is an incredibly organized process. Yes. So this has to be negative 4x up top. Okay, great. So then that negative 20x, we know this already, and that's 4x. And I'll be careful in this sense. This is 2. That's 10. Now what happens is that we have to put an extra column when there's a remainder, then it has to be an 8. So in order to get an 8, actually no, then you write this then. It's 3x squared. No, this is what you do. 3x squared. Actually, technically speaking, it becomes this. Actually, I'm glad you brought this up. Technically speaking, it becomes 8 over 2x plus 5. So you can write your answer like this. I'll explain in a moment. Why am I doing that? Because if I multiply this by 2x plus 5, right. See, if I multiply this by 2x plus 5, I know this times this gets me that plus 10. I need to have this extra thing here to get 8 more. Because I had 10 originally, I need 8 more. If you multiply by 8 over this.
So you can't just write 8?
No, it has to be, it's a remainder. For example, 61 divided by 12. What was 6 divided by 12 again? We saw, I said it already, right? It's 5, right? Okay. What if I did 61 divided by 12? It's 5 the remainder of what? 1. But was it really?
61.
It's 5 plus 1, 12. That's why I do the remainder over the divisor. Because that's truly what's happening. You have a little fraction next to the polynomial. So now we can answer this question. Evan wants to find that root. Sorry, he wants to find the other roots. So I'm going to have you guys graph these eventually. Right now, you're not ready yet. But if you think about it, if 2 is an x-intercept, what's the factor?
-2.
Perfect. So now we can do this. And the hope is that it comes out clean. If not, then that's another type of problem which we're not ready to talk about yet.
Can you just talk about the oh, you mean the
No, how to graph a polynomial with a fraction. I haven't taught you guys to do that yet. I want to touch because I graph polynomial. So, and that's the leading term is x cubed. Now, what are you going to multiply to x get to x cubed?
x squared?
So it's negative 2x squared. Now, if you think about it, I need a 2x squared along the diagonal. What are you going to add to negative 2x squared to get to 2x squared?
4x squared.
Yep, it's a puzzle. You got it. So that's 4x, negative 8x. What are you going to add to negative 8x to get to negative 7x?
X.
1x, yes. That's 1. And that came out nice and clean. Because if you look at the diagonals, they all add up.
How do you write that? Just like
X squared plus 4x plus 1. So x squared plus 4x plus 1 times x minus 2 equals all this junk here. So we just factored it out without realizing it. Division is factoring. So this times this equals the original polynomial. So if I solve this, I know that's 2, right? How would I solve this quadratic? Is that factorable?
Yeah.
It is? What multiplies 1 adds up to 4?
Nothing.
Nothing. So what are you going to do instead?
Right.
Quad form, yes. You got to quad form it. But you can find it. I trust you guys could quad form it.
This be calc section or no?
Yeah, it would be, yeah. Oh, I'd be totally cool with this in calculator. This is totally fine. I have no problem. I just want to see the work.
Like if we quad form that on our calculator, we can find that.
Well, I need an exact answer. But I'll provide the quad form for you guys. I don't care. 16 minus 4ac.
Yeah. I know.
Was that sorry? She didn't. Yes.
Oh my
And I
god.
still have her exact voice.
I can do it.
Memorized in my head.
I showed a class with her. It was really. You guys were funny when you guys were in a class.
Yeah.
And winds up becoming this. -2 plus or minus √3.
That happened to them.
There we go. Yeah, we're gonna do it right now. So anyway, that if you think about it, if you graph it, you're gonna get -2 as an x. Sorry, 2 as an x. So you get some 2 other wacky ones. Let's just do this really quick in Desmos, and then I'm done. And there's a lot of. Let me erase. No, I'm gonna erase this part right there. It's a little distracting. So you gotta quad form that polynomial. Did I do it wrong?
Question.
Yeah.
It's 2a, right? So a would be 2. And why'd you do -4 times 1 times 1?
Crap. Guys, I made a mistake.
Oh, Mr. E.
Okay, I made like 3 mistakes today. That's okay. Yeah, my bad, guys. The answer is just -2 plus √3. My apologies. But I was gonna check my work. Okay, I was gonna check my work. If I go to Desmos, y equals, can you guys give me the component x cubed? I got plus 2x squared minus 7x minus 2. Okay, so definitely it's crossing at 2, and it crosses these other two weird places. That happens to be -2 plus √3 or -2 minus √3. It happens to be that. So it will work itself out. So cool. Okay. Homework is attached. So these are CPM problems, but I decided to make the copies for you. So they should fall in the next couple pages. So once you guys get head start on homework, quizzes, I'm not gonna have a chance to grade. So don't
Even if you
worry.
did get it wrong.
You'll have a chance to retake quizzes during the next class or office hours. If you do want to see the quiz solutions, tests we'll talk about another dates as well. Quiz solutions, here we go. And if you do want to do a retake or office hours, oh, Reggie, let me get you started. Oh wait, Reggie, you haven't done it yet. Hold on. Sorry, I need to start on the quiz. Sorry. No, do it. You're working out right now. No. You know what? I'm not gonna talk with the quiz. I'll just keep my mouth shut. Just work on homework. Work on homework. All right. Here we go.